All right, so today we are going to be taking our set of notes on electron configuration. And you can see our essential question by the end of these set of notes, we want to know how do sub-energy levels, sometimes called suborbitals, shape the periodic table. So we should know a few things about the periodic table already. We know that the elements are kind of organized by atomic number or the number of protons. So they're organized in that way. And we've also heard about energy levels. So we know that atoms can have up to 7 energy levels and that they're organized on the side here according to whatever energy level that they have their electrons in, up to 7. So 1, 2, 3, 4, 5, 6, 7. And we should also know at this point that it's organized some way to do with valence electrons as well. And that the way it's organized helps us know how many valence electrons are in certain groups. But we shouldn't know, like, why is there this big gap in the middle and there's these pillars up here and what's going on with this block of elements down there? Those are things that we're going to be answering in this set of notes. So we're going to be learning a lot. The first thing we got to do is jump in and figure out what are energy sublevels. So I'm going to make a little table over here. We're going to be writing our energy levels down. And we got 7. So we'll just number them 1, 2, 3, 4, 5, 6, 7. There we go. We got 7 energy levels done. So as far as these energy levels, remember they start off small. Our first energy level is really small and they get larger and larger and larger as the energy level gets bigger because they get farther away from that nucleus. So this first energy level we said can hold only 2 electrons. So I'm just going to write the number of electrons down here just as a little refresher for us. So that first energy level can only hold 2 electrons. That second energy level, it's farther away from the nucleus. It can hold more. So we're going to say that one can hold 8 electrons. Energy level 3, it's getting farther away. That one can hold 18 electrons. Energy level 4, 32 electrons. And theoretically, the larger the energy level gets, the more and more electrons each energy level can hold. Now we're going to move into something new. That should all have been a review. We're going to move into what is a sub-energy level. So we're going to write our sub-levels down here. And our energy levels, we give our energy levels numbers. Our sub-levels, we give them letters. So our first sub-level, I guess to start off, let's back up a step here. Each of our energy levels will have as many sublevels as that number is. So energy level 1 will have 1 sublevel. Energy level 2 will have 2 sublevels. Energy level 3 will have 3 sublevels, and so on. So that first sublevel that energy level 1 will have is the S sublevel. And it is our smallest sublevel. It is our first one. As we go to energy level 2, it will also have an S sublevel. And every energy level will have that S sublevel. But because it's a larger energy level, it will have another sublevel. And that second one, we give the letter P to. So our first energy level just has an S. Second energy level, now it has an S and a P. If we go to our third energy level, we got a new sublevel. We got the S one still. We have the P. And now we got a D sublevel. And as we go down to that fourth sublevel, we have to add another sublevel. So we got the S, P, D, and the F. And here's kind of the good news. Theoretically, every energy level that we go down, we add another sublevel. But there's only so many elements on this periodic table, right? Well, it turns out that after we hit F, none of the other sublevels get filled in with elements. So we can almost kind of draw lines just going straight down here. And SPDF, those are the only other sublevels that we have to worry about. So now if we bring out a periodic table, and I'm going to write on the side of here our different sublevels. We'll write it right here. And our goal today was about the organization here. So sublevel, we had S, P, D, and F. And as far as electrons go, helium, even though it's over here because it has very similar properties to our elements on this side, our noble gases, we, for this example, are going to move it all the way over here next to our hydrogen because it has 2 electrons, just like these all have 2 valence electrons. And now what I'm going to do is you can now see our periodic table is made of a bunch of blocks. And I'm going to color these blocks different colors because these blocks are going to represent our energy sublevels. So remember, our energy levels are represented by these rows, and our sublevels are going to be represented by these blocks. So I'm coloring this one green, and this one I'm coloring right here. We are going to call this one our S block, or our S sublevels. There, now we got it color coded here. And if you take a look at the far side of the periodic table, this big giant square right there, that's going to be another energy sublevel block. This is going to be our P block. Remember, we moved helium over, so helium is not included in the P block. That is in the S block over there. But all these elements are going to be in the P block. And what that means is they hold their valence electrons. Some of those valence electrons are in that P block. Make that P block this color here. And then the next block we got is our D block, and we got this beautiful rectangle right in the middle of our periodic table. That is our D block, and you may have heard that name, transition elements. This is our transition elements right here. They have some valence electrons in that D sublevel. So there we go. But we're not quite done yet, because we can't forget about this last block here. This happens to be our F block. Oh wait, I almost forgot. We got a color in that D block. So we got them all color coded. It's easy to forget about this block. It's too easy to forget about it. What we want to remember is it's supposed to squeeze in right here. This is its spot. So if we're reading this periodic table like a book, left to right, going across this way in order of our atomic numbers, it's going to go from here, and then it's going to go down here, and then all the way across, and it squeezes back. Oops. It's going to squeeze back in there. So it all squeezes right in here. This is squeezed right in there. And this is what we call our F block. I'm just going to color this one yellow. There we go. And we can't forget to color this one. And now if we want to think, how many electrons can fit in each sublevel? Because we can see these sublevels, they are not created equal. They are not the same size. So let's take a look at our maximum number of electrons that can fit in each sublevel. And this is This is pretty easy to think about here. All we got to do, look at how wide it is, how many elements fit in each energy sublevel, and it's just 2 for S anyways. So 2 electrons can fit in each S sublevel. And if we take a look at that, it makes perfect sense because we said energy level 1, maybe I'll put energy level here and label it. Energy level 1 has 1 sublevel, and that sublevel can hold 2 electrons, just like energy level 1 can hold 2 electrons. If you take a look at our sublevel P, count how many electrons it can hold, 1, 2, 3, 4, 5, 6. Which also makes sense because if you take a look at energy level 2, it has a S sublevel and a P sublevel, and it can hold 8 electrons because it has 2 plus 6. 8 spots for electrons. If you look at D, count it across, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 spots for electrons, which also makes sense because our energy level 3 can hold 18 electrons, we said. 2 plus 6 plus 10, 18. The math is working here. And if we go down to our F sublevel, count them across, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Some of you may not have even had to count because you recognize this pattern forming. We add 4 each time. We got 14 there. So in our energy level 4, we have those 4 sublevels. 2 plus 6 plus 10 plus 14 happens to be 32. That's where that number comes from. Theoretically, if there was a G sublevel, if we had enough elements to put electrons into a G sublevel, we would assume that it would have a maximum of 18 electrons that could fit there. But that's all theoretical, so we don't gotta worry about that. So now that we know, we got our energy levels and we got our sublevel blocks, like what does that tell us? So I'm going to start, numbering everything on this periodic table because it's all useful and it's going to help us with understanding what electron configurations are. So I'm going to start here with when you write the electron configuration down, you start with the energy level. So energy level 1. Then you write the sublevel down. This is our S block for sublevel. So 1S. And that's where the electrons go in those elements right there. And we're going to start at the top left corner, go across, go down to the next line, and go across just like this. So we're just following the atomic numbers on the periodic table. So our next electrons are going to go in the second energy level, in the sublevel S. Those are going to get filled in. After 2S gets filled in, we're going to go into 2P. So energy level 2, sublevel P, and those electrons are filling in that sublevel. From here, go down to that next line, 3S, fill those in. Then we go to 3P, fill those in. And this is where things start getting tricky for the first time. We know there's a sublevel D that needs to get filled in. But the thing is, some of these sublevels and the energy levels, they start to overlap at this point. And it turns out it is easier for electrons to go into the 4S sublevel than into the 3D sublevel. So if you ever get confused, just look at how the periodic table is organized. It has all the answers right here. So take a look. We go 3S to 3P, and then it jumps over to 4S. So it's all organized already for us right here. And then this is one more bit of confusion here, because we know from 4S we go into that D block. And it's in period 4. So we might initially think 4D, but we have to remember there's a 3D right here. So this is going to be our 3D sublevel, even though we're in period 4. And what this period 4 tells us is not what energy level all the electrons go there. It's what energy level our valence electrons are in. And because we have a 4S right here, the valence electrons are held in that 4th energy level still. So that's why we're in period 4, even though we're writing 3D here. So we're going to fill in 3D next. And then we just keep going like normal for a little while. From 3D, we go to 4P. 4P, count in the next line, 5S. 5S to 4D. Fill in 4D. From 4D, go to 5P, and we're rolling again. Our next difficulty comes here, right after 6S. So we're going to 6S. You can't forget our F block. So we go straight from 6S down to our F block. And remember, our first energy level that has an F sublevel is 4. So we're going to write 4F here. And we'll go all the way across from 4F back to the D block, so 5D. Across there, 6P, and look at that. We are now on our last row of the periodic table, 6P to 7S. We just started filling in that 7th energy level. 7S, sliding down here to 5F, all the way across, from 5S back to 6D, and we're going to fill in our last sublevel is 7P, right across. And you might be like, wow, okay, this seems like a lot to remember, but really all we have to remember is our energy levels and our sublevels and where each one starts. So sublevel S starts with 1, sublevel P starts in energy level 2, sublevel D starts with 3, sublevel 4 starts with F, and everything else is just perfect order of the periodic table. So you might be thinking, what is the whole point of electron configuration? So let's do an example, and I will show the importance of being able to label where every single electron is of an atom. So let's do one example here. Electron configuration of nitrogen. So the first thing we got to do, where is nitrogen on this periodic table? So you need to bust out another periodic table that has all your elements. We can see nitrogen's right here. So it turns out nitrogen is right here. And what we can do is we could start writing this out. First thing, energy level. Well, we got to write all the electrons out. So starting at the top, it's got electrons in that first energy level. It fills up that first energy level, 1s. And then you put here, the exponent is how many electrons go in to that energy and sublevel. So 2, because that fills it up. The next energy sublevel that gets filled in, 2s. So 2s, we fill it up. We give it 2 electrons there. From here, zip across, zip to 2p. And this is where our element is. So we got to count across how many electrons go in to the 2p sublevel. So 1, 2, 3. And what we got right here is the electron configuration for nitrogen. And let me show you all the information this gives us. This gives us how many electrons it has. If you count all the exponents and add them together, 2 plus 2 plus 3, nitrogen has 7 total electrons. If you take a look at only the largest energy level, so we got energy level 1 here, 2 and 2. If you take a look at only the outermost energy level, which is 2 in this case, and add those electrons together, that will give us our valence electrons. So in this case, we got 2 plus 3. Nitrogen has 5 valence electrons. And that will help you for almost all of our elements here in knowing how many valence electrons we have. There are other ways, especially with our representative elements, to help us with valence electrons, but this is a very powerful tool for later on in chemistry.